data. What is the use of processing the data? What is the use of processing the data? Can anyone tell me? My question is, what is the use of processing the data? Why we need to process the data?
Getting track of the data.
Repeat, guys.
Having the track of the data.
I didn't get what you were trying to say.
Having the track of the data. Keep the track of the data.
Keep the track of the data. Okay. Anyone else? Why do we need to process the data?
To generate valuable information.
To get the valuable information. Very good point. To get the analytics. The valuable information is nothing but analytics. What we do with the analytics? What we do with the analytics? We will take a business decisions. Business.
We can forecast certain things as well.
Yeah, please go ahead.
We can forecast certain things as well. We can do trend analysis.
Yeah. So based on the analysis, we'll improve the business. We'll take some business decisions. We'll do a campaigns. We will do discounts. So to improve the business, decidedly to improve the business. Okay. It will give a value to our business. It will give a value to our business. Yes or no? So to get this analytics, what we are doing? We are processing the data. Data processing. So how we are processing the data? There are different tools available in the market. In that, one of the component is Hadoop. So it is not only data processing tool, it is data storage as well. It is not only data processing tool, it is data storage tool as well. Data storage tool. Data storage as well. Why should I need to store the data? For the future analytics. Okay. So why should I go with the Hadoop? Can anyone tell me if anyone has a basic understanding? Why should I go with the Hadoop? Because it has
a large amount of data.
Yeah, to store the large amount of data. Yes, because Hadoop has better data storage capabilities, better data processing capabilities. How it is better, we will see now. Okay, so we said data processing in old days. So to process the data, we need the data, right? Yes or no? We need data. If you want to process the data, someone should give a data to you. Yes or no? Yes, no. Could you please?
Yes,
yes. We get more interactive session. We do not have any question and answers. Okay, we'll be asking on the fly itself whenever we get a doubt. So to process the data, someone has to generate a data. Whoever generates the data, we will call them as a source. Data source. Who are they? They can be anything. They can be your financial sectors, they can be your social media, they can be your CRM application, CRM or ERP application, they can be satellites, they can be your applications or mobile applications or your mobile, anything it can be. It can be your car, it can be anything. Okay, what they do, they will generate the data. They will generate the data. They will generate the data. So as whatever the data they have generated, we'll call them as a raw data. We call that as a raw data. Why we will call that as a raw data? Because the data is directly generated from the source. We have not taken through any process, and the data contains valuable information and unvaluable information. It means necessary details and unnecessary details. The data can be duplicate, the data can be in a different format, the data can be any format, which we cannot directly take any analytics on top of it. We have to process the data. So very simple example I'll tell you. If you take an example, if you want to drink a mango juice, what do you have to do? First you have to select the mangoes, then you have to nicely peel off, then you have to cut it into small pieces, then you have to put into mixie, and you have to add what sugar or milk, whatever you want to add, you will add, and you will get this. What it has happened, you have taken the raw mangoes, you have done some process, right? You have not directly squeeze and drink the raw mango, right? You have taken mango, you wash it cleanly, and you have peeled off, and you have done something, right? Similarly, if you take a rice or if you take a wheat, if you take anything, we are not directly taking the raw. Why? Because it has a necessary information, it has unnecessary information as well. Here also same guys. So whatever the data is generating by the source, it has a necessary information, and it also will have a unnecessary information. What we need to do for that? We have to take the valuable information. How to take the valuable information from the raw data? We have to do ETL process. We have to do ETL process. What is the ETL process? What is the ETL process? Extract, apply some transformation, transfer, apply some transformation, and extract the data, extract from here, transfer, and load into some location or database. Extract, transfer, and load. Extract, transfer, and load. Why I'm telling you transformations? Because we will apply some rules and regulations on top of it. I mean, some business logic will apply. That's the reason I'm calling transformation. It is actually transfer. Okay. So once you've done that, what you'll do? You load the data. You load the data into a storage, a central storage. That central storage will call data warehousing system. Central storage will call data warehousing system. Okay. Why we need to store into data warehousing system? Why we need to store into data warehousing system? That there is some difference between the data warehouse and the database. Please try to aware that. Database system, data warehousing system. There are two types of systems. Please aware that. What is the difference, guys? What is the difference?
Storage of data of one server is known as database, and joining of many server, many databases is known as data warehouse.
Okay, but there is another main difference. There is something called database is used for OLTP. Data warehousing used for OLAP. Okay, try to understand what is this. Okay, I'm parking aside. Please try to understand aside. Anyway, I'll explain that later as well. Okay, so now look at here, guys. So I have taken the raw data. I have used some ETL tools, and in the ETL tools only, we'll do the normalization as well. Then we load the data into data warehousing system in the form of tables. Why we need to load the data in the form of tables? Why we need to store the data in the form of tables?
Well, I had higher expectations.
Sorry, someone said some answer. Ajit, Amit, Arif, please tell me, guys, why we need to load the data into tables?
To read it in a readable format.
To readable format. Okay, still
Ease of access.
easy of access. Correct. It's very simple, guys. Easy to
And
access. Easy to
data
access.
also we can categorize.
Okay, yeah, it's very simple way. Easy to access. Easy to apply any transformation on top of it. Okay, since we'll be having a schema. Now we have loaded the data into data warehousing system. Why I said data warehousing system, there is a meaning for it. Okay, I'll tell you. So after that, what we will do, we will have something called report generations, or we'll apply some well AP transformations on top of this data warehousing system, and we will generate the reports. So to do all this process, we need a better machines. Yes or no? With a good amount of RAM, with a good amount of processors, right? With a good processors to generate the reports in given amount of time. In a given time, right? So what we need a better machines to process it. We need a better machines to process. Then you will do a blah blah, and you will write some select queries, or you will use some UI to select it. Then you will click on submit. Then what will happen? It will generate a select query. Why select query? Because we will be generating the report. To generate the report, we will select the data. After selecting the data from the selecting data, whether you will go for visualization or you can directly take into some CSV files for the analysis. That's up to the end users or end business users. So what is the use of generating the reports? Those reports will be making use by whom? Business analysts, business users, data warehousing administrators, blah blah blah, who take the business decisions, right? Then they will take the business decisions, and then they will go with the whether they want to do a campaign or whatever they want to do, they will go with it. Yes or not? So now tell me guys, how this design look? It looks very easy, very simple design. This is how the data is getting processed in the traditional way. This is how the data was getting processed in traditional way. It looks so simple and so easy. Then why should I go with the Hadoop? This design has designed some decades before. Some decades before. Let's take I think it more than 30 years before it has designed. What is the data? What is the data volume at those days? What is the data volume those days? In the 80s or in 90s? What is the data volume? How many of you have seen the floppy disk? How many of you seen the floppy disk? How many of you are aware the floppy disk? How many of you aware the floppy disk?
I've seen it.
I have seen it, okay. Anyone else? Floppy, F-L-O-P-P-Y, floppy disk. What is the size of the floppy?
Our hand size, palm size, maybe.
Not physical size, storage. How much it will store? How much it will store?
MBs of data.
1 GB.
MBs.
Doesn't. No. It was 1.4
MB,
MB,
256.
1.44 MB.
MBs.
It is 1.44 MB. It means those days we were using such kind of devices to store the data. If anyone is using 1 GB RAM or 2 GB RAM in those days, it's like we used to surprise like it's a very powerful machine for us in those days, right? If anyone using 2 GB or 1 GB machines, it's really surprising. It's a very good machines those days, right? Now mobile itself has the 8 GB, 16 GB. Mobile itself is having that much memory, right? So when it designed this source, I mean this design, when they have designed this architecture, those days the data was very less. Keeping in mind that they have designed this approach and it was easy approach to process the data. Easy approach to process the data. Keeping in that mind the generation of the data what they are getting and what are the tools they are using, so it's efficient to process it. But current current we are living with a lot amount of the data. We are getting generated terabytes of the data in a day, terabytes of the data in a day, or petabytes of the data in a day. So this architecture is not fit. Doesn't mean that it will fail. It's not fit. It's not give better efficient uh, efficient way of processing the data. Why? Let's look at here, guys. As I said, it was well fitting when the less amount of the data. When the data grows, we have to go with the better ETL tools, which are licensed, which are licensed, which are not open source. They're not open source. You have to pay for by number of users. User wise, you have to pay, right? So we have to go with the better ETL tools, and we have to buy a lot of. So it is involved cost. Anyway, he has spent some amount of money. Then coming to here, he has to, since the data is grown, he has to upgrade his database system. Again, he has to go with the, when you want to upgrade, so there is a lot of issues with upgrading the old, I'm talking about a very old approach. Okay, those days you have to shut down the, you have to put in the maintenance mode, and he has to upgrade the services, or he has to upgrade this. So there also the cost is involved. There also the cost is involved, correct? And he has spent some amount of money, Coming to the process, let's say since the data is become huge, and also we may need to generate the reports for the huge data, right? Let's take a simple example. I have this environment in US, United States of America, or USA or somewhere, and I'm processing the data. I'm processing the data from India. So how does it matter, sir? Really no matter when you are in the same network. When you are in the same network. Since it is in a different mission and this is in a different mission. This is a different mission and this is the different mission. The data has to travel. Let's take an example. I'm taking 100 GB. Just taking 100 GB example. This 100 GB has to, when I want to apply the transformation here, the 100 GB data has to transfer through a network and need to download into this disk, this machine's disk. This machine's disk. The data has to transfer from through a network and it has to download into this machine. And it has to load into the RAM for the processing. Why? Because all the process will go in the RAM only. Any process you take, the process will go in the memory. It means you have to read from this disk and you have to write into this disk. So let's say the data transfer rate itself is taken 2 minutes of time. Data transfer itself is taken 2 minutes of time and the data processing is taken 1 minute of time. Totally I have taken 3 minutes of time to generate the report. So 3 minutes is a good amount of time to generate the report. What is the market standards? And people are looking for how many seconds they want to generate the report. The standard time is, or benchmark is 5 seconds. 5 seconds. So why? Because here it is taking more time for the downloading itself, right? More time it's taking for download itself, and sometimes it's taking for the process. So the second limitation what I'm showing here is time consuming process. It is a time consuming process. Why it is time consuming process? Why it is a time consuming process? The data has to transfer from one location to another location. It means the data is moving towards your computation. What is your computation? Select is your computation. Your data is moving to select query and processing it. So we are missing data locality here. Data locality, the most important feature. What is the data locality? What is the data locality? Data locality means instead of moving your data from one machine to another machine, you move your logic from one machine to another machine. Let's say here I have a data. I have written some logic or I have written some code. So code is here. If your data is moving towards your code, that is called code locality. That's called code locality. Let's say you have data and your code, you have written some code to process that, and you are sending the code towards data. That's called data locality. Why, sir? How it is different, sir? What is the problem? How it is different? I mean, what is the difference you see? There is a huge difference, guys. The data is in size GBs or TBs. Petabytes or exabytes or whatever it is. But when whatever the code you write, what will be in size, guys? The code is maximum your projects in MBs only. If your complete projects will be in MB only. So you guys tell me now, downloading the terabytes of data is easy or Uploading MBs of code is easy. Downloading terabytes of the data from one disk to another disk is easy, or sending your logic, computation, whatever you have written, sending that towards the data is easy. Uploading your code is easy.
Sending logic is easy to the other
Why? Because
system.
it's a very small amount. Sending logic is easy, and execute that logic in that machine and take the results. Right? That is called data locality, guys. It's called data locality. Okay, I don't think any example I can say. Very simple. You go and buy the items, or if you order the items through online, so you save a lot of time. You save a lot of time, right? So that's the difference comes. But anyway, there are some other advantages. So I'll go to store and I'll find the quality. I can touch the items through my hand and I can see that, and I can spend some time with my family outside. There are also other advantages, but when you want to save a lot of amount of time, and that time you want to watch your cricket or your favorite channel, or that time you want to spend with your family, you can do that instead of you travel through it or through travel on this traffic and all those things, right? So data locality is the best feature of Hadoop, one of the best features of Hadoop. I'll tell you why. Okay. second one is second one is I mean the fourth one, I mean to say. So one is there is no data locality, and fine, no, not a problem. I have downloaded the data, I'm processing it. So the process is a sequential process, guys. The process is sequential process, no parallel process. There is no parallel process. There is no parallel process. Why? Since it is in a single machine, I'm talking about old architecture. Since it is in a single machine, the whole data has to be processed here, even though it's a multi-core, but it is single processing only. If something goes wrong with that machine, you lost. The job will fail. If something goes wrong with that machine, the job will fail. Okay? There is no parallel process. Anyway, we know that the parallel process will take more amount of time. No, sequential process will take more amount of the time. Okay? Why there is no parallel process? No data distribution. No data distribution. Data distribution means keeping the data into multiple machines for the parallel process. Why there is no data distribution? Because no automatic replication. Automatic replication. What is the automatic replication? Keeping the backup, guys. As soon as the data comes, you are taking the one more copy for just if something goes wrong, the system should not fail. So the data should be available because the data is more important than hardware. So no replication available. Since you do not have a replication, no fault tolerance also. And so on, we have some kind of limitations are there. Some kind of limitations are there. Okay, while I am processing the data, if this machine goes down, my job will fail. While I am processing the data, if this machine goes down, my job will fail. To avoid that, if I have another machine here, it has the same replication of this, same data will be available in this. While I am processing the data, if this machine goes down, I can get the data from here and process it. That's called fault tolerant. So we have a backup. The people may say that, hey, I'm taking the backup. No, you're taking the backup schedule wise, every day 11 o'clock or every day night or something. As soon as the data arrives into this, you're not taking the backup into this. This machine also, processing machine also. If this machine goes down, you don't have another machine to process immediately. These are the limitations of traditional data processing system. Any doubt so far, guys? Any doubt so far? Ajit, Amit, Arif, Chandrasekhar, Farjana, Kaumudi, Madhavi. Guys, please. Any doubts? Venkat, Sweta?
No, sir.
No. Good. Good. Okay. Now we'll discuss about other approach. Then we'll go with the Hadoop. Okay. So why this design was working fine? Why it is all of a sudden it started facing a problem? Because of data is grown. Because data is grown. So can we say it's a big data? The cause was big data. Can anyone tell me what is a big data? Can anyone tell me what is the big data? What is a big data, guys? Anyone? Hosanna, what is a big data? Kaumidi, what is a big data?
It's a very large amount of data.
Very large amount of the data. Okay. Okay. It's a very large amount of the data. The huge amount of the data. That's it. How much huge? Is there any measurement? See, if the data is this much, then I can say it's a big data. Is there any measurement like that? Okay. So can I say 100 MB is a big data? Can I say 100 MB is a big data?
No.
Why? Why? I'll say 100 MB is big data. So can I send 100 MB as an attachment, not a Google Drive other, as an attachment through Gmail or any emails or any email application?
No.
So for that application, the 100 MB is a big data only. For that application, the 100 MB
Yeah.
is a big data only.
Yes.
So then what we understand? The big data is
Depends on.
the data which is not able to process with the current system in efficient manner. That data for that system is a big data. Big data is nothing but a huge amount of the data. We can say it's one of the factor. Big data, huge amount of the data which is not able to process by using a current system in efficient manner or in a given time. That data will call big data for that system. Big data for that system. So the big data has been classified into three categories. Not only big data, guys, ideally data has been classified into three categories. Can anyone tell me what are they? Can anyone tell me what are they?
Variety of data.
Variety of the data. Okay. What is the three categories? First category is
Velocity.
structure type of data. First category is structure type. Second type is unstructured. Third type is semi-structured.
Semi-structured.
How the data has been divided into three categories, how they have divided, they should have something to divide, no? If the data, if the whole data follows same delimiter and a single delimiter, we will call that is a structured data. The whole data follows single delimiter, we'll call it a structured data. An example, your database tables, guys. You take all your database tables, any database table, they are divided by columns. Maybe the column number of columns may vary. One table has 2 columns, another table may have 200 columns. Only the columns vary, but the delimiter is column only. You take Excel sheets, XLS. You take a CSV file, comma separated files. You take a TSV file, tab separated files. Such kind of files, formats, we can call them as a structured data. Structured data. Coming to unstructured data. Can anyone tell me unstructured data? And examples for that?
Dates, numbers.
What is that?
Dates, numbers.
Dates, numbers. So are they unstructured? Unstructured data means the data will not follow any data. Sorry?
Yeah. They are typically text very heavy data, which contains data, dates, numbers.
No, your date, comma, number, comma, again something, comma. So it is structured, right? You have a comma separated, single delimiter. You can actually pick up these values easily, right? The structure. So when you say unstructured, images,
Alphanumeric.
audio, and video. These are the typical unstructured formats of type. I mean unstructured type of data. When it comes to semi-structure, all falls under here. Text, log files. Actually, log files falls under structure, but failure logs. There is failure logs will falls under this. Okay, log files, your Word documents, your XML. XML actually falls under structure if it is a simple XML. If it's a complex, falls under semi-structure. JSON also falls under structure, but if it's a complex JSON, falls under semi-structure. Why? So very simple, guys. JSON will be key value pair. Let's take an example. I have a name. The name will be there. ID will be there. Salary will be there. Date of birth will be there. So the whole data will be divided into key value pairs. If for such kind of data, this is one record. If I have one more record similarly, that is simple structure. We have only one delimiter, which is colon, right? But the complex JSONs looks differently. So I'll show you the complex JSON. Anyway, we'll process them outside. XML also, if you have a parent tag and a child tag, then close the child tag and you close the parent tag. If it has a simple XML, it's a structure only, but the child tag has another child tag, that has another child tag, that has another attributes. That is one record. Another record comes in a different form. So that kind of data will fall on the semi-structure, but structure will be there. To get the actual extractions, you have to go one level down. Okay, so these are the examples for the categories. So these are all high level, guys. No need to go in the detail and a deeper manner. Why? Because these are all not quite really important for the interview purpose. Or we just need to understand what they are. That's it. Next, this data has some characteristics. Data has some characteristics. What are they? Volume, velocity, variety, variability, veracity, visualization, value. There are few more V's, guys. One book or one blog says that different kind of V's, but as per my knowledge, these are the V's. Volume, how much amount of the data we are dealing with. How fast the data is getting generated will tell by velocity. And variety, different types of the data. Variety, different types of the data. Variability, my source is giving structured data now. After few days later, one of the applications started giving you different kind of the data. Variability is not stable. It is a variable. It can change. Variability. Veracity, how good the data is. How trustworthy the data is, because we're getting the data from different sources. How worth it is. How good the data is. Visualization, whatever the data I have processed, we will be putting into visualizations. And value, the reports, guys, visualization is nothing but graphs and all this. Value, whatever the data we have processed, we should get some value out of it. If we don't get any value, there is no point of processing the data. There's no point of processing the data. Is that clear? Is that clear?
Yes.
Yeah. So these are the big data. What is the big data? Classification of the big data into three categories and the characteristics. This is about the big data, guys. Now come to alternative data processing tool, which is called Hadoop. Now we are going to actually see into what is Hadoop. Okay, so let's see now. What is Hadoop? Anyone? What is Hadoop? Farzana, what is Hadoop? It's a file system. Sweta, what is a Hadoop?
It's a file system. Hadoop is a file system.
Hadoop is a file system. Okay. Ajit, Venkat,
Distributed files.
Venkat. No, whatever you understand, whatever you know, whatever you read from here and there, you just tell me. We will correct it. No problem. If it is correct, well and good. If it is not, we'll correct it.
This is a framework for distributed storage and processing.
It is a framework for distributed storage and processing. Very good. Shweta,
It's a data modeling tool.
it is a data modeling tool. Okay. Another Shweta. Shweta, yes.
Hadoop is a Java-based open source framework to solve the problem for big data.
Very good. Okay. Anyone else? Okay. Hadoop is Java-based framework. It is a Java-based framework which will store the large amount of the data in efficient manner, which will also process the same data into parallel fashion or efficiently. What is a Hadoop? Hadoop is a Java-based framework which will store the large amount of the data, which will process the large amount of the data in an efficient manner or in a given time. Efficient manner or given time. So we're saying two things here. One is it will store, other one is it will process. How it will store? It has its own component called Hdfs. How it will process? It has its own component called MapReduce. Hdfs is for storing the data. For storing the data, MapReduce is for processing the data. Two different components are there. One is for storing the data, other is for processing the data. How it will store? Is it a database? No, it is not a database. Then what it is? It is a file system. What kind of file system it is? We have so many file systems in the market. What kind of file system it is? It is Hadoop distributed file system. What it is? It is a Hadoop distributed file system. Then what it is? This is map and reduce. This is map and reduce. We'll talk about that later. We'll talk about that later. So can anyone tell me what is a file system? Can anyone tell me what is a file system? Not a Hadoop case, normal file system. So each and everything has one type of file system. There are different type of file systems, guys. FAT file system, FAT file systems, NTFS file systems, ext4 file systems. There are different kind of file systems. What is a file system?
It stores the content or the information of the file that we created on the database.
Who actually manages your files and folders? Who actually manages your files and folders? Who actually keep a track of data is nothing but a file system. Who actually keep track of your files and folders? Who actually maintains your file system? Files, and who actually keep track of where the data is resided? That is nothing but a file system. Okay. So how this file system works? Actually, we will be storing the data into hard disk. We'll be storing the data into hard disk. The hard disk looks like this. The hard disk looks like this. And I'll be keep drawing this diagram. It's really important. People will understand easily with the diagram, so that's the reason. So I'll be showing you diagrams. So anyway, this diagram I'll be keep writing whenever explaining the file system. So whenever if you see your hard disk internally, it will be like this. And we might have already seen this diagram as part of our academic, or here or there we might have already seen. So this is our file system, hard disk, and these circles will call, what will call? What will call? Tracks. And these straight lines will call sectors. Okay. So whenever you want to store any data into this file system, any file system you take, the data will be break into pieces, guys. The data will be break into pieces. How it will break into pieces? So it will be having its own mechanism, its own block size. So your actual data will be break into pieces. And the normal file system, the block size is 4 KB. I'm talking about Linux operating system. Then these blocks will, these pieces will given by unique identification numbers for them. Then these blocks will store into this hard disk. We'll be having write ahead or read ahead, right? So some block will go here, some piece of data will go here. Some piece of data will go here. Some piece of data will go here. I mean, it's random. It will totally depends on how speed your hard disk is spinning and how fast the data is writing and reading. So this is will call as a blocks. This is a block. Now tell me what is a block? It's the most important interview question in Hadoop. What is a block? A piece of data. It stores in between two sectors. A piece of data which will stores in two sectors. Correct? Now already I have now what will happen, guys? Your file system, no? So normally your file system, it actually maintains the table. Okay, it actually maintains the table. The table is like the data.txt file has broken into these many blocks. These blocks are stored in these locations. Like that, will keep track. This is your file system. Your operating system will interact with the file system for reads and writes. Okay. So here, whenever you requested for the any file or reading, what it does, it will go to the hard disk. I mean, it will actually go to the file system. It understands that where and all the data resides. Then it will go to the hard disk. It will get that information. So reading from the hard disk and it will transfer the data. So we do have something called data transfer, guys. So the data transfer is by default 100 Mbps. The data transfer bandwidth is by default 100 Mbps, and the data what we read for each seek we'll call as a seek. For each seek we'll read a 4 KB of data. Since our block size is 4 KB, so it means we are reading the 4 KB of the data. We are sending through this bandwidth. We're actually not fully utilizing this data transfer rate. We're not actually fully utilizing the data transfer rate. Because of this, the systems are slow. Okay, and also we are reading 4 KB 4 KB. If you take a simple example, if I have my file size is 100 MB, 100 MB is a very small file. No, if you want to load the 100 MB into a normal file system, how many seeks it required? So you need to convert 100 MB into KBs, and you have a 4 KBs. If you divide this, it will be 256. It means 25,600. So you have to do 25,600 seeks for 100 MB data. So that's also one of the limitation. So block size is one limitation. It is not speed wise is a limitation. And also, let's say you are loading this file, okay, into disk. The file is corrupted, or the file is something happened, it get deleted. You don't have a backup. You don't have a backup, or you don't have a that you lost the data. Fault tolerant is not there. Fault tolerant is not there. Or you want to process this data, it is a sequential process. Even though it is a multiple cores are there, it is a sequential process. If this machine goes down while processing, you lost the process. I mean, the job will fail. So the limitations are there here with the file system. Because of this limitation, and Hadoop, since Hadoop handles with the terabytes of the data, no, the Hadoop handles with huge amount of the data. So normal file system is not fit for process the large amount of the data. That is the reason they went for another type of file system. Let's take a distributed file system. What is a distributed file system? Can anyone tell me? What is a distributed file system? Okay, so any doubt about the file system, first of all? Any doubts about the file system? Srikanth, Venkat, Sweta? Ajit?
No, we are good.
Ajit? Arif? Amit?
No doubt, sorry.
No doubts. Good. Okay. Okay. So let's go with a distributed file system. If everyone is good, then go with a distributed file system. What is a distributed file system, guys? What is the distributed file system? What is the distributed file system?
Distributed file system is a system which stores the metadata of all the data blocks which are saved in multiple machines, but for the end users, it looks like a single file system.
Okay, very good.
Having replication as well.
Okay, okay.
Parallel transfer of data.
Parallel transfer of the data. Okay.
It's a client server system which we can process the data from source to, client to server.
Client server mission. Okay. Anyone else? Anyone else? Okay. So distributed file system is nothing but distributing the data into multiple machines, guys. Distributing the data into multiple machines. Distributing the data into multiple machines. It can be one type of data, it can be multiple types of the data. It can be one type of data, or it can be multiple types of the data. Are you guys able to follow what I'm trying to say?
So Ravi Prasad here.
Yeah.
You need to say like it's a multiple type of data in the sense like does it take all the, as you said, structured, semi-structured?
Yeah, anything, correct. It can be anything. Yeah.
Okay.
It can be anything.
Okay, thanks.
Anyone else? Anyone else? Okay, let me explain you guys. Okay, let me explain you what it is, a distributed file system. Let's take a simple example. I have different types of data, guys, here. Okay, I have different types of the data. I have sales data. I have production data or products data. I have marketing data. Okay, three types of data is there. Now, when I load this data into single machine, it has to be processed in a single machine only. So it is a burden on the single machine. Like that, blah blah will run. But let's say I brought multiple machines here. I brought multiple machines. Since we have a three type of data, I brought three machines. Let's take an example. Then all sales data I have loaded here. All products data I have loaded here. All marketing data I have loaded here. And I have connected all these three machines into one central server. I have connected to one central server where they have connected to this server, and there, so whoever, it's called DFS, guys, or NFS, networking file system, NFS. And whenever a client came and he want to process a data, so as soon as he really no need to log into this machine separately, guys. He really no need to log in this machine. He really no need to log in this machine. He really no need to log in that machine in the network file system. If he log into one machine is enough, he will be able to access other machines if he has the permissions. Now, as soon as he log into the network file system server, he will be able to see all sales data here. He will be able to see all products data here. He will be able to see all marketing data here. He will be able to see that since he will be having permissions. Okay. Now, if you want, for with respect to him, it is looks like the whole data is resides in a single hard disk, but the data is not actually loaded into a single hard disk, multiple hard disks. So for him, this is only the file system. For him, this is only the path. He will log into this path and he will see whether the data is available or not. So similar like our shared drives in offices, guys. So there will be shared drives. You just go and log in there. You will see a lot of different types of the data. But whatever access you have, you can access only that much. You cannot access everything. So again, this authentication comes into picture. Here, okay. Now, sir, anyway, I already have a distributed file system. No, then why should I go with the Hadoop distributed file system then? Then why should I go with the Hadoop distributed file system, sir? I'll explain that. Let's see what is the limitations of the distributed file system now. So suppose I want to process the sales data. What I need to do, I have to log into network file system. I have to go here. Ideally, I'm actually I go here in the sense ideally I'm processing here. So I'm processing the data. Here my data block size is 4 KB. The same limitations whatever we have seen in the file system, same will be there. And why in case of processing it, if this machine goes down, we will lose the data. We do not have a replication. We do not have a replication for the recovery purpose, right? It's not highly fault tolerant. No sequential, no parallel process since the data is there in the single machine. Whole sales data is the single machine. That's what I meant to say. Production is also same and marketing data also same. So here also the similar kind of limitations. No parallel process, no replication. Okay, the no fault tolerant. So that limitations are there. So what they have done, so even Hadoop distributed file system, or if you take a normal distributed file system, which is called network file system, it's called network file system is already available, but that's not suit for the bigger amount of the data to process. So that's where they started. That's where they started. They come up with the Hadoop distributed file system. They come up with the Hadoop distributed file system. What is the Hadoop distributed file system? That's what we are going to see now. What is the Hadoop distributed file system? Any doubts so far? Okay. So now let's
Ravi,
talk about
the layer. Yeah, Ravi, the layer is there, right there, sale, PD, and NFS. What's that layer exactly? What's it mean? What's it
this layer is something like you actually see the path. Let's say you are accessing the shared drive. How will you access? Slash slash something slash something slash something, right? So actually for this path, whatever you're accessing underneath, you will be having a multiple machines. But for you, it is looks like a single path, correct?
Okay.
The shared
Yes.
drive also,
Yes.
it looks like a single hard disk. So that layer it is. Okay, nothing else.
Okay. 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 Thanks.
Others? Any questions? Okay, so before getting into Hadoop, Hdfs, so please take a quick break. Okay, it's a 8:22. Take quick break in 10 minutes and please join back and we will discuss about Hadoop distributed file system. Hadoop distributed file system. So how it is efficient than other file systems. So that we will be discussing today. Okay, please take a quick break and come back. Any doubt, guys? So anyway, I'm available. If you guys have any doubts, please ask me. I think who didn't attend last session. So are you guys able to follow? Like Ajit, Sairam, who didn't attend last session? Not only Ajit and Sairam, anyone. So are you guys able to follow?
Yes, Ravi. This is pretty much clear. So thank you very much.
Yeah. Okay. Now when we go for HDFS, we'll understand the different components in that, and that makes you more clear about the HDFS file system. Anyone else has any questions?
Roughly, do you have any time, like by when we would be completing all this course? I mean, roughly how much time this would take?
Your course duration you're asking about?
That's correct.
Okay. So the main components like HDFS, Spark, and Scala will be covering first 2 months. Within 2 months, the main components like HDFS, Hive, Scoop, and Scala, Spark. The rest of the components, there will be less priority with respect to interview and with respect to organizations. So that will be covered after 2 months. It means total the course duration will be comes close to 4 or 4.5 month course, if no breaks in between. Okay, so like sometimes you'll have a long weekends or um, uh, long weekends. So what we'll plan something, right? So if no breaks like that, it will be completed in 4 months or 4.5 months.
Okay.
But this time we are planning, actually earlier our flow was different. Like earlier we used to take first HDFS, then we used to take a Scoop, then Hive, then we used to take Java, then MapReduce, then that was the fashion we were covering before. But now the industry has changed, and if you in your profile, if you have Spark, Scala, or Spark main, whether the Scala or Java is no matter. If the profile Spark, Kafka, if these components are there, then your profile is getting shortlisted. Else, it is not actually not looking at. So the Spark will become a more important component. So everyone is using Spark these days. Everyone using Spark. So that's the reason we bring the Spark before. Since it is an individual component, it will work on top of HDFS. But HDFS is the first or base one. So we will be covering HDFS first. Then we will be in the Scoop. Then we will be Scala, Spark, or Hive. We will start in that manner. 1 second, guys. I'll just close the door. There is a temple nearby my home. Yeah. Any other question? It is a 120 bigger block. Why bigger block? Why bigger block? You can maintain the less number of metadata here in the file system, less number of metadata, and less number of seeks. If you take the same example, if it is my block size is 128 MB, how many blocks will come, guys, for 100 MB file? My file size is 100 MB. My block size is 128 MB. How many blocks will come? One block only, no?
One block.
Then it's easy to seek. At a time, it can seek 100 MB and it can transfer through your 100 Mbps transfer rate. It can easily transfer. We're getting we reduce the number of seeks. That is the reason. Increasing the block size in Hadoop. It's also one of the interview question, guys. Why Hadoop block is bigger than a normal file system block? because to reduce the number of 6 and to reduce the metadata information. If it is 4 KB, I have to maintain 25,600 blocks information in the file system. But if it is 120 MB, only one block information will maintain, right? So to get benefit of this too, the Hadoop block size is bigger. It's also one of the interview question. Okay, coming to architecture. So it's a block size is 128 MB, and also we were keep talking before replication. That is here the replication is 3 by default. Replication is nothing but duplication for the high fault tolerance. We will see now. So as I said, it maintains the master slave architecture. As I said, it maintains the master slave architecture. We need a two type of machines. One is master machine. The master machine will call name node. They have individual names. And the slave machines. Slave machines. Slave machines will call them as a data node. Look at guys here. They all connected to the name node. It is like I always like to take this example to make people easily understand. We have a team manager and we have a team members, no? So we'll be reporting to team manager, and he will be what he will be doing? He will be keep monitoring us, and he will be assigning the task, and we will be sending the status. So he is the master, and we are the slaves. Are we? And who actual work is doing? Is a team member or team manager? Team member only. Doesn't mean the team manager is doing nothing. He will also doing some some work which is belong to his role, right? Like managing the project and managing the people and maintaining your maintaining the information about you guys, like who is strong in what area, and if any one work comes to whom to assign, such kind of things will be managing by manager. And there are some technical managers who also assign the task to them, and they will be fixing the they will be developing and fixing. That's a different story. Okay, so similar architecture here also, guys. Similar architecture here also. This is a gateway node or edge node. Since we cannot directly talk to the name node, so gateway node or edge node is required. So we will be interacting with them to interact with the cluster. It's called Hadoop cluster, connecting all small machines and making as a single big machine is nothing but a Hadoop cluster. So these data nodes will be keep reporting to the name node, guys. What is the interval of reporting? 3 seconds, guys. Every 3 seconds. So based on the heartbeat, we'll call every 3 seconds. They will send a signal. Based on that signal, your name node decides these machines are alive or not. These machines are in the network or not. Based on that heartbeat, it will decide whether these machines are alive or not, or these machines are connected with him or not. Okay. Now this is also looks like a distributed file system only, correct? Yes, this is a distributed file system. This is the distributed file system only, right? We said Hadoop distributed file system. What it is? It is a Hadoop distributed file system. Understand, guys? So here, master is name node, slaves are the data node. Here, the actual data will store here. Let's say whatever the data you are loading, logs or whatever the data you're loading, actual data will store into data nodes. How it will store? I'll explain that. The master, what he does, he'll actually manages the data nodes. He actually assigns the task to this guy. Actually, he is the single point of contact. Suppose a new client came in our project. A new task came, or new client came. New client means new task, new project. He will directly come and meet you, or he will go and talk to manager first. He will go and talk to manager first, right? Similarly, everyone, if anyone wants to talk to us, they have to go through managers. Similarly here, if anyone wants to talk to the cluster, they have to go through name node first. I mean, before that we have a gateway node. We have to go through the name node. Is this clear? High level. Now these machines also all are connected together. The machines, all machines work as a bigger machine. Let me show a simple example. We have taken sales, product, and marketing data, right? Let's take first sales data. Let's take first sales data. Sales data. This is my sales data, guys. How the data will store into Hadoop I'm showing. This is sales data. So actually, if you want to store the sales data, you have to tell to where it is stored, right? We have some Hadoop commands, guys. We have some Hadoop commands to load the data. We have some Hadoop commands to load the data. The first command is here. The one of the command is here. It can be Hadoop FS or Hdfs, DFS. We will talk about that.
So is this a Linux cluster?
It's a Linux cluster, correct. So the Hadoop cluster will be Hadoop will be created on the Linux cluster only. Yeah, please go ahead.
Linux. Yeah, that was my question. That's it.
So Windows also supported, Hadoop also supports on Windows from the Hadoop 2 onwards, but no one will go with that one. So we know that. So all the servers will be Linux servers only, since it is open source. There are so many advantages. Okay. So when I execute this command, what will happen? This file has to put into Hadoop. Where I will execute this command, will always execute the commands in the gateway node only. Will always talk to gateway node only, no other machine. Why? Because that is the only mission the access is given to us. Okay, that is the only mission the access given to us. Because if we directly interact with the name node, there are the possibilities we can corrupt it. Since the name node is a single point of failure, if name node goes down, complete cluster will go off. You cannot access anything. Okay, now look at here, guys. I'm taking the sales data. So as we know that any data we want to load into any file system, what will happen? First the data will break into pieces, no? But what is the piece size here? 128 MB. Here the piece size is 128 MB. Let's take an example. The sales data is more 350 MB. Or yeah, you take 350 MB. So you can divide by 128. How many pieces will come? Those many. Okay, let's take a three pieces came. Here the gateway node, wherever you execute a command, that will call as the gateway node. In that node, when you execute a Hadoop FS command, this gateway node will launch in the sense it will create an object, Java object, which is called DFS client. Okay, this DFS client will go and talk to name node saying that, hey master, one of my client wants to write the data into you in the Hadoop cluster and tell me whether can I go ahead and write, or is there anything else I need to do. So what your name node will do, first it will verify something. What it will verify? It will verify one, the user, whoever is executing commands, whether he's authorized or not. Second one is this path is exist or not. If this path should not be exist, if it is exist also we can override. I'll show you that command in the real time. Okay, whether the destination is exist or not. should not exist. Normally should not exist. Even though if it exists, if we use minus f here along with the put command, it will be success. If these two are success, your name node will respond to the gateway node saying that, hey, you can go ahead and store, no problem. Then gateway node, what it does, it will actually break the pieces now. 3 pieces, piece 1, piece 2, piece 3. 3 pieces is broken. Piece 1 is 128 MB, piece 2 is 128 MB, piece 3 is the rest of the size. 128, 128, 256, and another in 350. If you take out the 256, it will be 44 and plus 50, 94. That's it, no? Yeah, 94.
So
Go ahead.
this is a structured, unstructured data, or shall we say is ETL data
No
that we
matter
are
whatever
loading?
the data you put into Hadoop, it will be break into pieces. Any type
Okay.
of data you want to put into Hadoop, as soon as you execute this command, the data will be broken into pieces and load into multiple machines.
Okay, so let's say structured data we are loading using the command.
Still it will
Okay.
break into pieces. I'll come to your point, Ajit. I understand you. So if it is a structured data, if I put into Hdfs while processing, will it be a problem? That's your doubt. I'll explain that. Okay. So let's see. So once it is broken, no courtesy. Simply it will go ahead and break it with a physical cut. No matter whether it is starting of the name or ending of the name, or starting of the field or end of the field. No matter, no courtesy. Once it is reached to 128 MB, just break it. That's it. It will start with the 0 bytes, and it reaches to 128 MB, break it. That's it. Okay. No matter at all whether it's a field in middle of the field or end of the field, or never mind. We'll just do a physical cut. Okay. It will cut and it will store into Hadoop. I'll show you that how it is. Now, once it is broken into pieces, it will take the first piece, guys. This is quite important. Please listen me. Okay, it's a little important. What it does, it will take the first piece. I'll change the color here. It will take the first piece. Then it will go to the name node. Who does that? DFS client, HDFS client or DFS client. Okay, he will take the first piece and it will go to the name node, saying that, hey master, I want to, as requested earlier, I want to write the data. The block size is 120 MB. The replication factor is 3. Okay, give me the 3 different machines to store the data. Then your name node, as I said, no, this data nodes will be keep reporting to him. They will be keep sending the heartbeat every 3 seconds. Based on that heartbeat information, and based on, there is 2 things, guys: block placement policy and rack awareness. Block placement policy, rack awareness. Based on these two, the data will be then loaded, and also the machines will be identified. Based on these policies, the machines will be identified. Okay, let's look at here. So in my bigger cluster, to store this data, and as the client requested, hey, give me 3 machines because I need to load the data. Based on these policies, he will choose the right machines now. Let's say he chosen the machine 1, he chosen the machine 3, he chosen the machine 5. Guys, as I said, it is random. Okay, based on the policies, it is random based on the policies also. So no, it is not like always it will choose 1, 2, 1, 3, 5 only. No. Okay, it can choose anything. Okay, it choose on the 1, 3, 5, and also your name node actually maintains that information, guys. So someone requested for this, so that information maintained for name node. So what is the sales data? Block 1, Okay, now look at here, guys. So your name node chosen 135, that IP addresses will give to the gateway node. That IP address will give to the gateway node. While giving, it will sort based on the network distance. It will sort based on the network distance and it will give to the client. How it will sort? Who is the nearest to the client? Who is the nearest to the client? That node will be given to gateway node first, and the next nearest one, next nearest one. So it's like 1, 3, 5. It will be given like this. It will be given like this. Now your gateway node will remember this information. It will put into cache. I mean to say, it will put into cache memory for the future purpose. Now your gateway node has a block, a physical block. No, then it will go and talk to the nearest machine, which is 1. Then it will tell to that machine, hey, you need to talk to that other machine as well. Since it has the information about it, it will connect. And it will also tell to this machine 3, says that we go and connect with the machine 5. Then once the pipeline is created, this is called pipeline, the data will start transferring through it. Okay, so the data, it will come to the first packet, and first will come to the node 1, the same will send to the node 3, the same will send to the node 5. So for 3, who is the sender? 1. For 5, who is the sender? 3. Yes or no? Now, as soon as it receives it, machine 5 will send an acknowledgement. Hey, I have received. Sorry. Because the sender is machine 3. For him, machine 3 is the sender. He will send the acknowledgement to him. And he will send the acknowledgement to him. Then he will send the acknowledgement to him, saying that we received the packet, send me next packet. Like that, it will repeat. Once he stores successfully one block here, one block here, one block here, these guys will report to the name node saying that, hey master, we have stored this piece. Where and all it is stored? Piece, it is stored in the machine 1. Second one is the next machine is third one. So it will also store into 5. It means one block of sales, it is stored in 3 machines. One block of sales data stored into 3 machines. As soon as they store successfully, they will tell to the name node saying that we have stored successfully. The name node will make an entry into these machines. I mean into the metadata. And next to block 2, it may store 1, 2, 3. Next to block 3, it may store 4, 5, 6 or some randomly, guys. It is not always maintained the same. Similarly, it will go with your marketing data as well. If you observe here, whole sales data has not stored into single machine. The whole sales data has been broken into pieces. Those pieces are stored into multiple machines. It means the data has been fully distributed across the multiple machines. The data has been fully distributed across the multiple machines. Are you guys getting what I'm trying to say? So if I want to process the only sales data, I can go with a parallelly. I can go 1, 2, 3, 4, 5, 6. So I don't need those many. Since it is a 3 blocks, I can choose 3 different machines. I can choose, suppose, let's take an example, guys. Okay, let's take an example. Now I want to process the sales data. What I do, let me take a different color, black. Okay, I want to process sales data. What I do, I have written some code, and the code came to gateway node, and it is processing from the gateway node. Let's look at here, guys. So when I want to process the data, block 1 can be processed in machine 1, block 2 can be processed in machine 2, block 3 can be processed in machine 5. It means the sales data itself is getting processed by 3 processors, 3 different machines. Correct? We have a parallel processing here.
Could you please come again to that point actually, the parallel processing point once again?
Okay. Now the whole sales data in how many machines?
3 missions.
Not 3, several machines. 3 into 3, 9 machines.
Yes. Yeah. Correct.
3 into 3, 9 machines, correct?
Yeah, 9 missions.
Including the replication, including the duplicates. Now, when I want to process the sales data, I have written my code. I'll tell you what is the code you have to write. That is either Hive or Spark or MapReduce or whatever the code you have written. Then you submitted that. Then what your name node will do? Hey, you want to process this data? No, fine. So the block 1 process in the machine 1. Process block 1 here. You process the block 1 here. Block 2 you process here. Block 2 you process here. Block 3 you process here.
Okay. So the amount will segregate the systems.
Correct. So the whole sales data is getting parallelly processed. Very simple, guys. Okay, this is my file. Okay, divided into 3 parts. This part is processing by task 1. This part is processing by task 2. This process is processing by task 3. Then they will take the consolidated result. Divide and conquer. It is something like divide and conquer.
Ravi, I have doubt here.
Yeah, please go ahead. Yeah.
Actually, I'm confused between the gateway node, name node responsibilities actually.
Okay. So.
And also DFS client.
Okay. FS client is a Java object. Okay, just a Java class. Okay. The DFS client which will be running on the gateway node. Okay. It's a small Java instance. Just understand that way. Coming to the gateway node. Gateway node is an entry point to your cluster. It is an entry point to your cluster. You cannot directly go and talk to the Hadoop cluster. Let's say we are using I'm using my Windows machine. I want to talk to my cluster. Let's see a simple example I'll show here. Let's see a simple example I'll show here. Let's say my cluster is running. My cluster is running on this machine. I mean, let's assume that it won't be like this. It will be multiple machines will be running in the different location. It won't be in the same machine. Okay. I want to show you practically. That's the reason I'm showing here. It is actually a single machine here, but assume that in the real time, so many machines are there. If these machines are running here in the different location, and you want to connect to those machines, you want to connect to those clusters from your laptop, correct? For the development laptop or your desktop, from your machine, correct? From the development machine. Since we will be writing code in the real time, right? In the development environment, whatever the machines are assigned to you, either those machines can be Linux machines or those machines can be Windows machines. Most of the cases, those are Windows machines only. Most of the cases, those will be Windows machines only. Okay. So what you will do, the development and all you will do in the Windows machine, the execution will do in the Linux machine. Okay. Now this is my Linux machine, which is running. Okay, let it run. Okay, let it run. Okay. Now, yeah, please go ahead.
So data processing is happening in gateway node or in data nodes?
Data processing will happen in the data nodes, but job submission from the gateway node.
Okay, so if I have an unstructured data, so job submission will be done at gateway node or gateway server.
Okay.
And then processing will happen at data nodes. Okay.
Correct. Very simple, Ajit and others. Wherever the data resides, where the data resides, data nodes only. Because as I said, data nodes are the workhorses who actually stores the data. Who are the machines? Which are the machines stores actual data? No matter with the structure, semi-structure, unstructured, the data will store in the data nodes only, always. Okay. Once the data is stored in the data nodes, the data processing also should go in the data nodes only, because of the data locality. If you guys remember, data locality. Yes or no? So the data processing will happen in the data nodes, but the job submission is there. No, executing the command execution will happen from the gateway node. You can also do from the name node. You can also do from the data node, but you will not be having access to directly them. You will be having access to only gateway node. Understand, Ajit and Sweta?
Yeah, Ravi, I have
And
doubt here. So
Yeah, please go ahead, guys.
the
in
data
this,
from
Ajit,
okay, go ahead, Ajit.
Ajit, please.
so this gateway node is also a Linux cluster.
Yeah, Linux machine, that also. It's not a cluster, Linux machine, individual machine.
Yeah, it's out. It's a gateway, so it's out of cluster, but it's a Linux machine. Okay, that's it.
Go ahead, Sweta.
Okay, yeah. The block one data from a gateway node, will it directly talk to name node, and from name node it will go to the data node?
No, that is wrong flow. Your gateway node, from the gateway node you executed the job, which is put command. I shown in the below, no? This command.
Okay.
Let me try it. This command. Okay. So as soon as you execute this put command, okay, in the gateway node, there will be DFS client. Okay, he will just take the information and go to the name node saying that, hey, I want to store this data. Give me the machines. It will just take the information. What is the information? Block size, and the replication factor. Okay, for this file, this is the block size. For this file, this is the replication factor. I want to store in the Hadoop cluster. It will go with that information. Name node, see, name node will not take data mark. Name node will not take data. Name node will not store any data which is related to your actual data. Name node maintains only metadata. Okay, Sweta, you're getting?
Sir, so 128 MB is the by default capacity for a master, or
Not for master, whole cluster, whole Hadoop cluster.
for the Hadoop cluster? Okay.
So the DFS client directly sends the data to the data node?
Yeah. First it will go and talk to the name node. It will get the information,
Okay.
where and all I need to store. Then your DFS node will create a pipeline with the data nodes. Look at here another example, Shweta. So you have a new client came into your project or your team. So he will directly connect with you, or you will go and connect with the team manager. Then he will assign the task. How it will happen? First, you will talk to the
Goes via
manager.
team manager.
Then
Yeah.
he will ask the team manager. He will talk to the team manager, and he will say, the client will say his requirement. Hey, I have some UI development. That UI development, I need a people. Please refer me some people. Then your team manager will identify who is the expert in the UI, and he will give those guys names. Let's say Prasad and Ajit. They're experts in that area. So what he will do, manager will do, he will refer Prasad and Ajit. You can talk to Prasad and Ajit, they can do that. Then the client will directly talk to the Prasad and Ajit, correct? He will send an email, or he will talk to, he will conduct a meeting or something. Then he will explain the task. Then Prasad and Ajit will actually assign the task. That's the normal way it will happen. Okay. Similarly, Hadoop cluster also, the gateway node will go and tell to the name node saying that I have something to store, give me the mission IP addresses. Give me mission IP addresses. Then gateway node will connect. Then gateway node will connect directly to the data nodes. Understand?
Okay. Okay. User authentication, you mentioned it. That will be performed by name node initially.
See, user authentication, since you are talking to Hadoop cluster, no? So to talk to the Hadoop cluster, whenever you are talking to Hadoop cluster means first your request will go to name node only, always.
Okay.
The request will go to the name node only, because if you want to talk to the name node, you should be authorized, right?
Right.
So that
So
will.
the name node will check whether you are authorized or not.
Sorry.
So the name node will check whether the particular thing is authorized or not while we send the request to name node.
Sorry, I lost your question. Could you please repeat?
No. You just go ahead. Sorry. So I just skipped.
Repeat. No problem.
So now you are saying about some authentication, no? Whether from data node it goes to the name node. So whether the name node searches whether that is valid or not, and next it sends a reply to GW or.
Yeah, gateway, edge. You can call edge, gateway, or client. Three names for the same mission. You can call edge node, or you can call gateway node, or you can call client. All three belong to that mission only.
That mission only. Okay, thanks.
Now look at here, guys. Okay, now let me show you one thing. Okay, let me show you the real time. So this is up and running. Data node 1. Now this is my client server, my client, or I can say this is my Hadoop cluster. This is my Hadoop cluster where all Hadoop services are running. Now I want to talk to this machine from where? From Linux machine. From Linux machine. So how will I talk? I need to interact with the.
When you are saying you are in a Hadoop cluster, so in this interface, are you in a name node, or you are in a data node, or you are in a gateway?
No, that's what you need to understand. This cluster will not be accessible for you directly. This will be there in the different location, somewhere else, or it can be in your
So you are
office
in a
only.
gateway.
No, that is not a gateway. I'm telling. Let me come to the gateway part. Okay. So this is a multiple node cluster, guys. Let's look at here. Let's look at. Okay, this is my cluster. This is my name node. This is my data node, and you will be having a gateway node separately. Okay, we will talk to this guy. It's called. You can call edge node also. You can call gateway also. You can call client also. All three same way. Now, see, your Hadoop services will be running on these machines. Your Hadoop services will be running on these machines. Okay, your Hadoop services will be running on these machines. Name node service will be running here. Data node service will be running here. Okay, if you want to talk to Hadoop cluster, you cannot directly talk to the name node. That is a restriction. Why? Because we may corrupt the machines. That's the reason. They will give one mission. Hey, whatever the jobs you want to submit, you submit from here. Whatever the commands you want to execute, you execute from here. Don't talk to name node, don't talk to the data nodes. Understand, Ajit, what I'm trying to say?
Right. So right now you are in the when you are in a gateway node. When you open the cluster, right?
No,
This
no,
is what I was
no,
trying.
no, no, no. Okay. Now let's assume that I'll explain in a simple way. This is my Hadoop cluster. Let's assume that I have a name node. I have a name node. I have a data node. I have some other services for the processing services also there. Let's assume that it's actually a single machine, single Ubuntu machine. Let's assume that it is a 5-node cluster. Let's assume that. Okay. This is a 5-node cluster. Okay. Now I cannot talk to this Linux services where it's running directly. I cannot talk to these machines directly. What in the real time they will do? They will give one machine like this, the gateway node. They will give one machine like this, the gateway node. They will give the gateway node like this. Okay. Now the login credentials will be given for this machine only. From where? From your laptop or from your desktop.
Okay. So using my laptop, I'm logging into my gateway node.
Correct.
And giving commands. Okay.
You will execute from here. Suppose if it is a Windows machine, you'll use putty or something else. If it is a Linux machine, you will use SSH.
Yeah.
Understand?
Yeah. Sure.
Shweta, is it clear now for you?
Yes, Ravi. Yes, Ravi.
From your desktop or laptop, first you will connect to the edge node. How will you connect? Either putty software, if it is a Windows machine, or SSH software, if it is a Linux or MacBook. Okay. Then here only you will execute your put command or your job submission. Everything you will do here only. That will go internally. It won't talk to the name node. Okay. Then it will start. So data processing or data storing will happen in these data nodes. Clear? Still, do you have any questions?
The transformation of data from name node to data nodes is happening from name node itself, right?
Data transfer will not happen now. I'm repeating one more time. Your name node will not at all take the actual data. The data node will not at all take the actual data. It will not take actual data. So the actual data will go from here. It is like from the gateway node to data nodes. Let me tell.
You mean to say the replica? So you mean to say the replica of the data will be a name node, or?
No, data won't be there in the name node. I'm keep repeating that. Your name node will not contain any data. Okay?
Okay.
It contains the references of
So
metadata.
name node just like
okay, let me put in this way,
so
guys.
name node just like acting as a mediator, like data node to gateway node.
Yeah, correct. Let me put in this way, guys. Okay, let's say Ajit is our master. Okay, let's take here. Ajit is a master, and rest of all we are all data nodes. Ajit is the name node. Okay, let's take an example. I am a client. I'm a gateway. Okay, I'm a gateway, and Sweta is a user. Sweta is the user, and she want to give some information to all other people. Okay, now Sweta will approach me. Why? Because I am gateway. So if anyone wants to talk to you guys, first they have to talk to me, because I will not allow Sweta talk to you guys directly. Okay, so I can also don't have I mean, it means that since I'm a gateway, I can talk to you guys. Since I'm a gateway, I can talk to you guys. So Sweta will come give a request to me. Hey, I need to talk. I need to give some information to the data nodes or other people. Please tell me where and all they are. Now she will ask me. Then I will come to Ajit. Hey Ajit, she want to share some information. Give me the best people. I'll say. So I'm not giving the information to Ajit. She didn't give me the information to me. Okay. So then I came to Ajit and said that, hey, give me the 3 best people where she want to share some information. Then what will happen? Since Ajit will identify 3 people. Let's say he identified Arif, Chandra, and Farjana. Okay. Ajit will tell me, take these 3 names. Take these 3 names. Okay. So now what will happen? Since he has given me 3 names, the 3 names I will give to Sweta. The 3 names I will give to Sweta. Now, Sweta what it does, Sweta actually shares that information through me to the other 3 people. So now Ajit doesn't contain the information, no? Is that Ajit has the information what she want to share? No. So similarly here, your name node will not contain actual data. So Ajit does not have actual information. Similarly, name node will not have actual data. The sales data name node does not have it. Only data node has the sales data. Only data nodes has the sales data. Clear, guys? It means in our case, Arif, Chandra, and Farjana has the information. No one else.
How it's choosing, Ravi? Only 3 nodes out of a number of nodes. Based on availability of data.
Yeah, Venkat, I told you here, no? It uses the block placement policy and rack awareness. Okay, your name node will choose. Name node will choose machines.
Okay, got it.
Out of all these machines, it will choose the policies. I'll tell you later. So it will make you confused. That's the reason I kept aside. Okay.
Okay.
So using the block placement policy rack awareness, it will choose 3 people only. Why? My replication factor 3. If replication factor 5, it will choose 5. The replication factor is 1, it will choose only 1. Like that it will work.
Is it a business decision to, I mean, if it is a 3-factor or 5-factor?
Correct. It's a business decision. Like importance of the data. You can change. You can configure. Even block size also you can configure. So by default 120/80. You can reduce to 64, or you can reduce to 32, or you can increase to any 8 multiples. Or I mean to say, like 8 bits we have, no? 8 bits, 1 MB, like 1020. 8 bits is 1 byte, then kilobytes. Like 8 is the divisible, right? I mean, obviously 2 also divisible for that. If it's 8, so 8 is a divisible. All 8 multiples you can have as a block size. There is a minimum block size, maximum
Is there
block size.
any limitation?
Yeah, there is a limitation.
Maximum sizes.
So maximum sizes we have seen in the Huttonworks cluster. It is I think 1 GB. It won't allow more than that. I'll get you that what is the upper limit of block size. But we'll never go with a bigger block, ma. That will be again a big problem. I'll tell you why. Okay, I'll tell you in a few minutes why it is why can't we go with a bigger block. So far, is it clear?
Yes.
I think your doubt is clear, Shweta. Is it clear? All your doubts?
Yes, sir.
Okay. Ajit, what about you?
I'm clear, Ravi. Thanks.
Yeah. Anyone else? Anyone else has any doubts? Venkat, Arjana, Chandra, anyone?
No, Ravi, it's clear.
Okay. So this is how the data storage, this is how the data process will happen. Data storage is happening in the multiple machines for the single data, and data processing will happen in the multiple machines parallelly. Okay. So what is the limitation you guys see here? What is the limitation in this architecture? In this architecture, there are a lot of other architecture changes are there. You will be having a 2 name nodes. You can have multiple gateway nodes. They're all different architecture changes are there. I'll show you. But you tell me what is the limitation you see in this architecture, or what is the problem you see in this architecture? There is a problem. Then what is the problem? Name node itself is the problem, no?
Data validation.
No, that's a data validation comes under process part. We are talking about the storage
Single
part.
name node.
Single name node and single point of failure, correct?
Yes, yes.
If name node goes down, nothing will be accessed. Name node is dead, nothing can be accessed. It is something like you have stored all the information in the data nodes. No one can go directly talk to the name nodes, data nodes. Okay, let me explain this another way, guys. Now data is there which machines? Data nodes only, no? The data is there in the data nodes. We don't have access to access the data nodes directly. Okay, the metadata is there where? Name node, correct? Metadata means block 1 is in this IP address, in this IP address, in this IP address. Block 2 in this machine, in this machine, in this machine. Block 3 in this machine, in this machine, in this machine. So that information is there. The reference, the metadata is there in where? Name node. If name node goes down, what will happen? The metadata also will go. If the metadata is not there, how will you know? How will you know sales data is there in which are the machines? You will not be knowing, right? That is called single point of failure. And single point of failure and data loss also. If name node dead or we are not able to in a position of recover, we lose the data also. We lose the data also. Clear, guys? Let's go to other. Okay, yeah, before explaining here, I would like to show you the cluster, the real-time cluster, how it looks. I would like to show you the real-time cluster, how it looks.
Ravi,
Yeah, please go
while
ahead.
you are doing that, when a user logs into gateway node and he submits a job, obviously a block of data will be picked up and it will be written into data node.
Correct.
So this block of data, where it exists?
In the data nodes.
No, I mean before.
It will be there in the
before writing.
Okay, before writing, either it will be there in the external server or it will be there in the gateway node.
It will be okay. So you are saying the job I'm submitting, that will have a description to pick up this data from this
Obviously.
location and
Correct.
write it into this location.
That is your
will
Hadoop
pass
command,
through
no?
the gateway.
Yeah, that is your Hadoop
Yeah.
command. Hadoop fs minus put your source. You are telling, no, where it is.
Yeah.
The source. This can be your gateway node path, or it can be any other FTP server or other server where you can get the data put into here and you can execute the command. Or you have a capability of, there is one command, same in a put command only. You can give the IP address and port number of this service and you can take the data and upload into this. Ideally in the real time, what will happen? The data will be put into the gateway node. From the gateway node only will be stored from the gateway node. Okay.
Yeah.
Yeah.
Normally by using putty also we will be doing SFTP, same put command and get command, same like this.
Same putty means I didn't get you, ma.
No, Ravi, I'm just saying like by using putty also we will be doing SFTPing to other server, right? From Windows to other server or one server to one server. Same thing we are doing here also.
Correct. Okay, so I would like to show you this one, right? These are all the things what we discussed. Okay, big data, how much big data, varieties, and these are all we discussed. But anyway, I'll take you guys this through a little later. I want to show you the real time how it looks. Yeah, these are all the real time cluster. You will be having racks like this. Okay, and these are all the nodes. These are all the nodes. In one of the node is name node, one of the node is a client, one of the node is secondary name node, or one of the node is a edge node. So we will segregate in that. This is one rack, this is one rack, this is one rack. Here we have a three different racks. These are the machines. Okay, if you look at here, they all are connected to internally. They all connected. Oh, sorry. If you see the blue wires here, they all are internally connected and they will be communicating each other. The communication between, I'll also explain you what are the protocols they use. The communication from the data node to name node, it is a RPC, remote procedure call. It uses the RPC. Why RPC? Because your data node is not sending any data to name node. It is just sending a small information. I am alive, and this is the block I stored. Block report and small information. So RPC protocol is enough. Who carries the small amount of information from client means your DFS client to name node. It's just an information. It is not passing any data. RPC protocol is enough there. But one data node to another data node, data is transferring. So it requires a HTTP. Clear? Anyway, I'll show that communication channels and all. No, not to worry at this point of time. It looks like this, guys. Okay, it looks like this. Ideally, your cluster, the bigger clusters will be like this in the real world. And look at guys here. The client is nothing but edge node. You have a secondary name node. You have a name node. Job tracker, task trackers, and all I'll tell you later. That is comes under the process map reduce part. Name node is in this rack. Client is in this rack. Secondary name node another rack. Rest of all are data nodes. So what we do? I want to store the data. What I do? First, you will connect to this machine, client machine. You will connect here, and you will execute the query. Then that will go and talk to name node. And name node identifies the machines from here, and it will I give the IP addresses to client. Client will go again, and he will load the data into data nodes. Client will not send actual data to name node. Understand? I hope this diagram is giving you a clear idea. Is it clear, guys?
Yes.
Okay. So now go back to the limitations, guys. Go back to the limitations. So you have, okay, let me show in the real time. Okay. Anyway, I have started the services. No, let me show you here. Now look at guys here. Not to worry what command I have executed for time being. I'll explain all the commands. Okay, I have ID, name, sales, tax. This is my data files. Okay, this is my data files. So when I load this data into Hadoop, as I said, it will break into pieces. The pieces will store into multiple machines, correct? So those multiple machines are like this, guys. So the multiple machines are like this. 1 second, I'll show you. here you can see that data node information, name node information. Go to the data node, current. This is a block pool. I'll also explain this in the coming classes. Current, finalized, subdirectory, and you have some subdirectories here. Who created this? Did I create it? No. While you are loading the data into Hadoop, that is created the subdirectories. Now you tell me, you are seeing here two files, no? ID, name, sal tags, withdraw, no, with the wrong data. Okay, I have these two data files. Now by logging into data nodes, ideally you are accessing this means you are logging into data nodes. So you are logged into data nodes. You tell me which file is belong to those two files. You can't tell. Why? Because these are the file names like a blk. Blk means block underscore some specific number. So by using these blocks, you can't tell, oh, this is belong to that, this is belong to that. You can't tell that. One second, guys. Okay, so now why I was telling you data nodes and all. If you go here, even if you log into data node, you can't recognize whether this data is belong to sales or whether this data is belong to products or the data belongs to markets. You can't tell that. That metadata will be there with only name node. Only name node can tell you that this is belong to whom, this is belong to whom, this is belong to whom. That information will only with the name node only. Name node only. Okay. Okay. So that is the reason we always talk to the name node. We'll always talk to the name node. Let me give one example, guys. Here, let me give an example, which is really the nice. I have taken this example from online. So let me give an example. Okay. Now I have some godowns. I have some godowns. Godown storage where I can store it. This is my godown. In this, I have in this row one godown 1, 2, this will make you very much clear. I'm very much sure this will make you very much clear. This example will make you clear. These are the storage rooms. This my godown. These are the storage rooms. Okay. And I have a front office. One office is there. I have one office. Okay, I have a front office here. And this is let's take numbers, okay? G1, G2, G3, G4, G5, G6, G7, G8. This is the entrance for your go down. Okay, this is entrance for your go down. This is office where you have the book and all will be maintained. Now, so you can store items in this, right? You can store items in this. So different cold storage, we have a hot storage, different storages are there. You can store in this. Now, let's take. I'm a farmer. Okay, I'm a farmer. So I have farmed something. Um, I have crafted a paddy. I have crafted 2 lorries of paddy. Okay, 2 lorries of paddy. Now this paddy is now the rate is very less. The market rate is very less. So I want to sell them later, but I cannot keep these 2 lorries of paddy, the paddy bags in my home, since my home is very small, right? So what I do, I have to put into some storage, some godown I have to store. Okay, so whether it's a government godown or private godown, right? Then what I do, I will approach to the office saying that I have 2 lorries of paddy. 1 second. Okay, so I have to approach to office saying that, hey, I have a 2 lorries of paddy. Let's say I have a 2 lorries means 200 bags of 200 bags. I have a 200 bags of paddy. In the 200 bags, let's take a segregation. We have a 3 parts, no? I mean 3 blocks. So let's take 50 are P1, 50 bags are P2, 50 bags are P3. Types of paddy. Okay, 50 bags are P4. I means I have a different type of paddy. I have P1, P2, P3, and P4. Now I approached to office, Godam office. I said that, hey, I want to store this 200 bags of paddy for some time. So I'll pay the rent. So godams are they meant for rent only, no? So then what he will do? He will come to here, and this officer, what he'll do? He will make a note. He will make a note in the book saying that Ravi or Veera, he brought uh, paddy bags, P1 type, P2 type, P3 type, like that. Then what he will do? Then he will tell to he will tell to me, um, you take lorry to the Goda, go here and put P1 into G2 in some specified row. If you, I don't know how many of been into get a chance to be into this. I have been here again. You will be having rows. There will be like a row wise. They will keep these paddies. Okay. So he told me keep your paddy in the G2. G2. P1 keep in the G2. P2 you keep in the G6. P3 you put into G4. P4 you put into G5. Now that information he made it in a slip. Who? That officer, the manager. Okay. P1 in a G1, P2 in a G6, and P3 in a G4, P4 in a G5. So he made that information. He has that information with him in the book, and he has given one receipt to me. One he'll keep on copy. Okay. Now look at guys here. If I go with the slip, he will verify that. He can easily get me where the P1 where the P2, where the P3, where the P4. You can easily get me that. Let's assume that I lost the slip and he also lost the slip. Without this slip, can I go and get where my paddy bags are there? Without this slip, can I go and get my paddy bags where they are in the godown?
No. No, we cannot.
Others, understand, guys?
Yes, Ravi.
We cannot get, right? Why? Because in that godowns, there may be so many bags. There may be so many customers will be there. You never know that. You cannot remember in which row, which bulk you have kept your paddy bags. You can't remember that until unless you have that slip with you, right? So this slip, whatever you're maintaining, no, this is like a metadata. So wherever we keep this slip in the book, that is like your name node. And these godowns, these are all like a data nodes. The paddy is like your blocks, data blocks, right? So what I'm trying to explain here, without intervention of the office or without intervention of this metadata, if you go to the, you can, since they are physically exist, even the data nodes are physically exist, you can go, if you have a permission, you can go inside, you can log in, right? But can you able to get the information where they are? Can you able to identify which are the bags is belong to you? We cannot. We cannot, right? So this is how the Hadoop cluster also happens. Even though the data, we know that the data is stored in the data nodes. We know that the data is the data nodes, but we don't know which form, where it is, and what is the block number. As I shown here, in the data nodes, the data will store like this, guys. The data nodes, the data will store like this. This is the data. This is how the data stores in the data nodes. PLK. If you go to another subdirectory like this, you won't be having information. So how will you remember these numbers? You don't have a mapping. Mapping is there to whom? Name node. Name node maintains this mapping. Understand, guys? You can't recognize by seeing this. You can't recognize by seeing this. Similarly, you can't recognize by seeing this, you entering into go down and by seeing them. You can't recognize which is belong to you. Okay, so that is what I'm trying to say. Your name node is a single point of failure. If name node goes down, you can't do anything. You can't access data. You don't know where the data is. You know the data is stored in data nodes, but you don't know what is the actual file or what is their numbers. So that information will be in the name node only. Clear, guys? Now, come to limitation part. Come to limitation parts. Let's talk about the name node roles and responsibilities. First, as Sweta asked, the gateway node responsibilities are talk to name node whenever the request comes. Whenever request comes. Okay, so the gateway node is used to execute the all your jobs. Okay, so your job client, if you think your job client is running in this, job client will job client is the person who create the data pipeline, who transfers the data. So we cannot keep them as the role of your gateway node. Okay, so you can take name node roles because name node is important one. Name node roles. Can anyone tell me what is the name node roles? What do you understand from the architecture or diagram what we have started? Who manages the cluster? Who maintains the metadata information? Who provides the resources? One second. Store data. What else? Single point of failure. Apart from this, it has one more role. It has one more role. Look at here, guys. This is my name node. Let's take an example. And this name node has to store the metadata, no? Has to store the metadata. How it will store? The metadata will store in the form of files. What files? The files are edit to file, edit to file. Other one is fs image. Two files. It will maintain the metadata in the form of two files. One is edit file. Other one is fs image. Are you guys able to follow what I'm trying to say? Okay, so what contains edit file, what contains fs image? That's important, guys. Please bear with me for a few more minutes. It's quite important. It is quite important for interview purpose or for your understanding purpose as well. It's quite important. Now, whenever we do a transaction with a cluster, with a Hadoop cluster, whatever the transactions we do with the Hadoop cluster, like creating a data, deleting a data, updating a data, or such kind of things, whatever you are doing with the Hadoop cluster, we will call them as a transactions. We'll call them as a transactions. Those transaction information will go into edit file. This is like a log file, guys. This is like a transaction files or a edit file. What it contains? It contains what is the operation. Okay, let me list out here. Edit file contains transaction ID, operation code, who did the operation, user, who did the operation, user belong to which group, what is the permission, and some other information, guys. I really didn't remember, but we all not require this for your day-to-day life. You will not see these things, but for your understanding, I'm explaining it. So it contains the raw transaction information. Okay, so what is the transaction ID? What is the operation code? Who is the user did? What is the group he is belong to? What is the permissions are available? And whether it's a directory or file, such kind of information will be there. Okay, now that information will not give a file system information, correct? What is a file? How many blocks are there in file? What is the block size of the file? What is the replication of the file? That information will not give. That information will be there in the fs image. That information will be there in the fs image. What it contains, whether it's a file or folder, and size of the file, replication factor, block size, number of blocks, size of each block, user, group, permissions, blah blah blah. This information will be there because it is a main important file for the file system information, where the file, which block it is belong to, all these things. Okay, so how that information will come into the FS image, how the information will come into this, how the information will come into this, how the information will come into edit file. Here, whenever we are doing a transaction, the transaction information anyway it will go in the RAM. We know that all the process will happen in the RAM, correct? So the transaction information anyway it will be there in the RAM. One copy will write into edit file. Okay, so one copy will write into edit files. One copy will write into edit file. So here, when you are writing one copy, it will maintain the edit log information. It is like a log information. Then it will keep doing a transaction. Whenever name node restart, look at guys here, at the time of restart, it will take the edit information, it will write into FS image. So edit file will get the information from the name node, FS image will get the information from the log file, which is called edit file, edit log here. So when FS image will get the information? At the time of restart only. At the time of restart only. At the time of restart only, FS image will get the information. At the time of restart only, the FS image will get the information. Otherwise, it will not get the FS. It will not get the information. Only the information will be there in the log file. Let's take an example. This is one of the role. Okay, whenever name node restart, take the edits from here, merge with FS image. That's a role. That is a role of name node. Now, let's take a simple example, guys. I have not restarted my cluster for 30 days. What will happen? Your edit log will become huge. Your edit file will become huge, very much huge. Then this file has to merge with this file, which will take longer time. Longer time to merge. Correct? It will take a lot of time. So what will happen while merging? What will happen while merging? Look at guys, this is quite important. While merging, your cluster will be in a safe mode. While merging, your cluster will be in a safe mode. So what is the safe mode, sir? What is the safe mode, sir? A read-only mode. Read-only mode. It means you can read the data from the cluster, but you cannot write the data into the cluster. It is something like a maintenance mode. Maintenance mode. It is something like a maintenance mode. Okay, safe mode is more important for interview question. What is a safe mode? They'll ask. Safe mode is a read-only mode. When it will go into safe mode will enter into two cases. I mean, actually multiple cases are there. Let me explain two cases. Safe mode will enter into two cases. One is at the time of restart. Second one, we can keep it manually by using admin commands. We can keep it manually. We can keep the cluster into safe mode manually. Another one is, this is important guys, this is important for interview. Third, when I have a more corrupted files in the cluster, The fourth one, there is some location where FS image and edit log stores if that reaches to threshold. That I will show you later in the configurations. But for timing, try to understand these three. Safe mode is the read-only mode. Safe mode is the maintenance mode. In the safe mode, you can read the data only. You cannot write. No job will execute except read job. Except read. No job will be executed in a safe mode except read job. Okay? No other job will read. Understand, guys? Safe mode is quite important for interview purpose. The last part is the safe mode. When it will go into safe mode. These are the three use cases will go into safe mode. Okay. So while merging, you can't write any data. That's also one of the limitation. Until the merge is complete, it will not come out from the safe mode. Until you complete the complete process, it will not come out from the safe mode. So if it didn't come from the safe mode, you cannot write any data. You cannot make use of your Hadoop cluster. You cannot make use of Hadoop cluster. You cannot make use of Hadoop cluster. That's one of the limitation. That's also one of the limitations. That's also one of the limitation. Understand, guys? So another limitation is if it is a huge transactions, the restart time will take more. If it's a huge transactions, the restart time will be more. Okay, how to avoid that limitations? How to avoid those limitations? Is that clear to everyone? This is quite important. Any doubts so far?
Yeah, Ravi, edit and FS image. Can you repeat once again?
Okay, edit and FS images are two different files for maintaining the metadata information. At the time of transactions, at the time of running, name node is running and someone is doing some transactions. At the time of that period, the transactional information will go into edit file. The transactional information will go into edit file. Edit file contains operation code, transaction ID, who did the transaction, is it belong to which group, what is the permissions, what type of transaction it is. That kind of information will be there in the edit file. Okay, but your name node require the file system information in the data node where the data is there, the data belong to how many blocks, what is the size of the block, what is the replication, that kind of information is required. So for that, what it will do, at the time of restart, it will take that information from the edit file. So it will not be visible for us, but internally it will process, it will take that information. So it will take that information, put into the FS image, at the time of restart. I'm telling guys, see why I need to do this one. When I restart the name node, will the information will be available in the RAM? Will the information will be available in the RAM? If I restart my cluster, will my name node contains the information what I was doing before? Will that will be available? Will that be available? I'm repeating my question, guys. My question is, I was doing some transactions. Okay, I was doing some transactions. That time my name node was alive and running. My name node was alive and it was running. And I have done lot of transactions. So my name node keep track of all this information because it is running. All the information will be there in the RAM. We know that all the process will go in the RAM only, right? Yes or no? Yes. At the time of running any machine, even if you take your mobile, if your mobile is running, it will be all the information will be there in the RAM at the time of it is running. Correct? If you restart your mobile, what will happen? Complete information will go. Remove the memory. I mean, it will clear the RAM. So that time you cannot get what was running before. Yes or no? So here also same. Here also same. So at the time of name node running, all the information will be there in the RAM. But when it restart, RAM in the RAM memory will be cleaned. So if the RAM memory clean, name node will lose the information where the blocks are there, where it is resides, and all the information will be loose. So to keep a permanent storage, they will put into the files. That information will be put into the files. How it will be put into the files? In the form of edits and fs image. So now whatever the information is there in the, it's like a slip. I told you, the previous example, the slip. They'll maintain the book and slip. Similarly here. So they cannot remember, no? They'll write into one file, right? Here similarly, your name node will write into these files. Okay. Then at the time of restart, it will merge, take the fs image. This fs image will be loaded into RAM. Then I will get the complete information. Then I'll get the complete information about the data nodes, where and all the data resided. Understand, Sweta?
Will FS image get the data from edit file?
Yeah, from edit file will get it. Correct.
The log information.
Correct. So to get the FS image, there should be someone has to do a merging process. Okay.
Okay.
That someone is nothing but name node. When the name node will do, at the time of restart only, he cannot do other while he is running. At the time of restarting only, he will do that merge process, and other times he will be taking care of the client requests, DFS client requests. Clear, everyone? Sir, how it will be limitation, sir? Then how it will be a limitation, sir? I'll show you that what is the limitations. So one is, let's take how it will be a limitation. If your edit is huge, as I said, if a edit is huge edits, it take time to merge with FS image, no? So till the merge process complete, name node will not functional. Name node will not functional until complete the merge process. So if you have 100 edits, 1 second or 1 millisecond, 200 2 milliseconds. If I have 1 billion transactions, it will take so much of time to merge, That's the limitation 1. Are you guys able to follow what I'm trying to say? Huge edit file, more time for restart. Second one, it is not merged. I have done a lot of transactions. It is there in the edit file. I have done a lot of transactions. That information is there in the edit file. Name node is dead. Name node is dead. Unable to recover the data. Unable to recover the data. Now data means this one, edits. Data means metadata, means to say unable to recover metadata. Now tell me, we lose the data, or still we can have access to the data? Name node is dead, we cannot able to recover the metadata. So there is a chance of losing the data, or still we can access the data which is there in the data node. I think any confusion?
If there's no backup,
no, forget about the backup at this point of time. Okay, so we are not yet seen the backup.
then data lost. Then lost.
Name node dead, then we will lost the data.
Correct. The backup node.
Yes.
Backup node is there in the architecture change. That's where we are seeing the evaluations. At this point of time, there is no backup node. Only name node, edge node, data node. I'll bring the other nodes one by one. So we lose the data.
Yes.
Venkat, Srikanth, Sairam, I think everyone is able to follow. If you guys have a doubt, please ask me, guys. Okay, don't hesitate. Okay. So that's also limitation. Losing the data is limitation. Restart time is taking. The limitation is there. No. To overcome that limitation, in Hadoop, what they have done, they hired one assistant. Okay. So assistant to whom? For the name node. One assistant to name node. That assistant is for the assistant. They have given name as a secondary name node. They have given name as a secondary name node. This guy is the name node. They hired one new assistant for the name node. Assistant, PA, personal assistant. So we know that data nodes are reporting to only name node only. Remember this one, guys. Okay. So whatever the while hiring the assistant, they have set some roles to him. What is the role of the secondary name node? Assistant. First role is every 1 hour go and talk to name node, take, edit fs image and do merge process. Second role is, hey, not only 1 hour, either 1 hour or 1 million transactions. 1 million transactions. Whatever happened first, either 1 hour or it can be 1 million transaction. Whichever happens first. So go take edit file, merge with the fs image. This is the role set to secondary name node. Now actually we are reducing the burden on the name node. Okay. So how it will work? Look at guys here. Look at here, guys. So guys, quite important. Be patient. Please be concentrate. Okay. It's quite important. Now my cluster started. We know that when the cluster started, when the name node started, it has its own edit file. It has its own fs image will be created. It's a fresh setup. At the time of 6 o'clock, I started. I'm keep doing a lot of transactions. At the time of 7, this guy, he has a timer. No, he'll be keep checking his watch. Okay, this guy keep check his watch. Then he will go and request, hey, give me the edit file and fs image, man, because I need to do a merge process. This assistant, what he has done, he has created a checkpoint here, and he has taken the edit file from here. He has taken the fs image from here, and he did the merge process. Then he created the updated fs image. He updated the fs image. Now at the time of 7 o'clock, since he has already given the old edit file, 7 o'clock he will create a new edit file. Then he will do the transactions. At the time of 8 o'clock, again he came, hey, give me that edit file, man. He created some checkpointing here. He took the edit file. Then he did the merge process. With the previous edit file, previous fs image. Now he updated the fs image. Now at 8 o'clock he will create one more He started doing the transactions. At 9 o'clock, again he came. Hey, give me the edit file because it's 1 hour is reached or 1 million transaction is reached. He took the edit file, merged, created, updated FS image. Now look at guys here. At the 9 o'clock he created his own new edit file. No, he's keep doing the transaction. At 9:30, name node restarted. At 9:30, name node restarted. It's quite important, guys. I want you to answer. At 9:30, restarted. So now, if it is a 1 hour, personal assistant is the responsible for. Secondary name node is the responsible for it. If it is not 1 hour, in between only failed. So who is responsible for the merging? Name node itself. Name node itself. So while hiring the secondary name node, will clearly said you do these roles only. We don't involve anything else. You do only this thing. So if he fails in between, that is the secondary name node responsibility only to merge. Now you tell me how much data secondary name node has to merge. How much data secondary name node has to merge?
30 minutes of data.
30 minutes of the data. Very good. It has to merge only 30 minutes. In the earlier case, when I don't have assistant, I have to merge from the 6 o'clock, right? Only 30 minutes of the data needs to merge. You can quickly restart. Second, at 9:30, the name node is dead. How much data we may lose? How much data we may lose?
Same 30 minutes.
30 minutes of the data only. Why? Because we have up to data till 9 o'clock. I have up to data FS image. Okay. So this is how they brought the secondary name node. But when you say secondary, what is the meaning of secondary, guys? The primary is not there. Secondary should act as a primary. Then only we'll call it as a secondary. Correct? But does it doing that? No. It is actually doing a checkpointing work. It's actually doing a checkpointing work. So for that, in the Hadoop 2, what they have done, they named it as a checkpoint node. They named it as a checkpoint node in Hadoop 2. So they realized it is a wrong name we have given, the checkpoint node, and also they have changed one more role here. The role is as soon as you did the merge, merge, you upload this FS image also. As soon as you merge, you upload the FS image also. Why? Because when the name node restart, it's no need to go and ask. It's no need to go and ask the secondary name node for the FS image file. If it is there with himself, he can merge aramse, right? He can merge himself, right? So that is the reason they have given a new role to checkpoint. So I hope you guys are following what is the checkpoint, what is the secondary name node. So secondary name node roles we explained before. Now we're actually explaining the second checkpointing node. Checkpointing node is actually same as your secondary name node, except uploading. I mean, your secondary checkpoint node has a behavior of upload the updated FS image to the name node. Upload to updated FS image to name node. I hope you guys know what is the difference between the checkpoint node and secondary name node. Now, still the limitations are same. Because only they change your name and they change the role of this. But still, half an hour, 30 minutes of data it has to merge for the restart. We may lose the 30 minutes of the data. Still, the issues exist. Issues are not resolved. 100% the issues are not resolved, right? It is just a small fix. So to resolve that, what they have done, they come up with something called backup node. They realized it. Hey, every 1 hour going and disturbing him. 1 hour is a default. You can reduce to half an hour. You can increase to 2 hours also. That's up to you. 1 hour is a default. You can reduce or you can increase. That is up to you. So they realized it. Every 1 hour he is going and disturbing the name node. Name node is not able to concentrate on his work. So that's a problem. So don't allow the doing a checkpointing. Avoid the checkpointing. So for that, what they have done, they brought one more mission. They replaced the checkpoint with one more mission. That mission is backup node. Here also the data nodes are reporting to whom? Only name node only. That's, remember that, guys. The data nodes are reporting to him only. Okay, the data nodes reporting to him only. So now look at here, guys. This is the main name node RAM. What they have done, what is the role of the backup node? The role of the backup node is sync with the name node RAM. Sync with the name node RAM. Okay, no 1 hour transaction, no 1 million transaction, no checkpoints. You always sync with the RAM, name node RAM. What if anyone did any transaction, that information will come to RAM. You take that information here. You collect that information. So here you do the merge process. You do the merge process in the backup node and give back to him updated FS image, because he need it, no, for his purpose. So here what is happening? No checkpointing, no longer time to restart, no data loss. How? I'll tell you. Whatever the transaction you do here, they will be reflect here. They will reflect here. Then he will take and he will create FS image. He will take and he will create a backup file. So whenever name node goes down, first scenario, take restart. Does he need to do any merge process? Does he need to take any merge process? Not required. He has up to date FS image. Just need to load the RAM. Restart is quicker. Second one, it is completely dead. He is completely dead. We lose the complete information from the name node. Do we need to worry about it? Do we lose any data? No. Why? Because the updated FS image is there in the backup node. When you bring the new machine, load this FS image and start work on it. So there is no data loss. Look at, guys, here the evaluation. Initially only name node, secondary name node, checkpoint node, now backup node. Do you guys see any limitation here? Do you guys see any limitation here?
No.
No limitation? Ajit?
Ravi, how backup node gets data backup?
How backup node get the data? So it is in a sync with the RAM, no? Name node RAM, it is synced. Synced means it's always talk to the name node RAM. So whatever the data comes to the name node RAM, that data will be dumped into backup node also.
Okay.
Understand?
Okay, yeah.
Now you tell me, what is the limitation you see here? Ajit and others. Still single point of failure is there, right? If name node goes down, can you able to access cluster? If name node is failed or dead, you need to bring one more machine. Till the time no one can access the cluster, you need to bring the new machine, then load this backup file into them, then you restart. So you have to spend almost 30 to 45 minutes of time. Till the 30 to 40 minutes of time, your cluster won't be available. Your cluster won't be available. Yes or no? So we are missing high availability. What we are missing here? High availability. It means always available. That is we are missing. So for that, what they have done, they have removed the backup node also, guys. They have removed the backup node also. Then what they have done, let me show you this. What they have done, oh, I think it's better to have new file. What they have done, let me clean up all this things. I don't want this. I also don't want this. Okay. Now they have brought one more machine. They have, they replaced the backup node with the standby name node. Important, guys. The current architecture is this. So far whatever we have learned, that is for only interview. So far whatever we have learned, that's for interview. The real time we see this. So they have named it as an active name node. They have named it as a standby name node. And you will be having a central repository. We'll call storage area network. And active name node will take care of, okay, let me put this as well. Okay, so that's how we can. Let's look at this, guys. So now these guys will report everyone. Both the machines they will report. So far they were reporting to only one guy. Now they are reporting to both the guys. Now they are reporting to both the guys. Means heartbeat will go to the both the nodes. The heartbeat information will go to the both the nodes. So at a time one machine will be inactive. At a time one machine will be inactive. This guy is active. What he will do? He will take all the requests. He will take all the requests. So he will put the edits into here. Edits into here. He will write edits. He will read the edits. He will read the edits and he will do the merge process. Standby name node will do the merge process. Merging, he will write, he will take and merge it. So after merging anyway, he will upload back. Okay, he will upload back. He will be having that upload back feature is already there. So merge updated files will be there in here. Now look at here, guys. So he will take all the requests. Edits will be there in the SAN, storage area network. Then the standby name node will read that information, will do the merge process. So this all will be monitoring by Zookeeper. This all will be monitoring by Zookeeper. And this guy will be reporting to the Zookeeper. This guy also will be reporting to the Zookeeper. So if an active name node goes down, since standby name node knows about all the information, since these guys are informing him also, these guys are informing standby name node also, Zookeeper tell, hey, you become active immediately. Then standby name node will become active. It's like a team manager and team lead, both are there in the team. If both are available, team manager will be doing a team manager activities, lead will be doing the lead activities. If a manager is not there, we know that our lead will become a manager, right? Same case, exactly same, highly available, so always available, no point of clusters going, so there is no data loss also. Clear, guys? This is called high availability, which is the current running architecture in all the organizations, small scale organizations or mid scale organization. But if you go with thousands of node cluster, there is one more architecture that I'll explain in the next session. If you have thousands of nodes, there is something called Hdfs federation. Hdfs federation, where you can have multiple active name nodes. Multiple active name nodes. When you go with more number of cluster, like 1,000 nodes of cluster. But current running, I haven't seen the federation cluster, but I have seen the active name node, standby name node cluster, multiple name nodes cluster. Any questions so far?
Ravi, once active node comes back from SAN, will it take the data back or from active from standby node?
It will take the roles. That's it. It will take the roles. I mean, standby name will become a standby, active will become active.
What about
Merging
the data?
Merging will be do a standby only. So whatever the rights it has written in the central area, so whoever become a standby name node, they have to take that file and they have to merge it. Understand?
Not in clear. Actually, standby mode will always be standby mode, or once the active node goes down, standby node will become an active node,
Correct.
right?
Correct.
So again, the roles will get exchanged once the active node comes back.
See, yeah, once active name node come back, so your zookeeper tell that, hey, you become standby, active will become active name node.
So Ravi, adding to Shweta's point here, like what even I wanted to know. See, active node got down for let's say 2 hours. Meanwhile, standby node is working. Okay, once it backs active node, so it will take the 2 hours of data from the standby to backup, or it will be like that only. No need of taking the data to backup.
So that information is there in the central area, right? Storage area network.
Right, Ravi. Yeah, got it, Ravi.
Yeah. So one second, guys.
So
one
you
second,
are
guys.
saying
I just one second. I'll just come. Okay. Someone is knocking my door. 1 second. Hey, sorry guys. Yeah. Ajit, sorry, you were asking some question. I stopped you. Ajit.
No, Ravi, I think I am pretty much clear. I was just reiterating Shweta's. So whatever requests are coming into the any of the active node, it gets written into the
Yeah. So,
SAN,
Sweta, why I'm
and
telling
if
that, no?
standby is live.
Why I'm telling that active name will become active, standby name will become standby, because while we are doing a setup, right? Environment setup. So they will specify the host names. So they will specify that which is the active, which is the standby. So your zookeeper will always listening to the host names, right? So zookeeper will recognize by the host names only, right? So based on the host names, if the active name node goes down, other one will become active. So as soon as the active become it came up, so the standby will become standby, active node will become active. Understand, ma?
Okay, since data is there in SAN, it no needs to get the data back from SAN, whatever the
It will be there in
data
SAN.
left.
So see, when it is active,
Yeah.
this will read and it will take the merging. Anyway, the name node is aware of doing the merging process, right? It will take the latest information from the SAN.
Yeah.
Okay. So this is about architectures, guys. These are all thing. There is one thing called federation, but at this point of time is not required. So I'll cover the federation later point later in the session. So if you guys have any questions, whatever the questions you have about the file system from the since morning we talk, please ask me.
Vina, I have one question here. Whether SAN and Zookeeper will talk each other?
SAN and Zookeeper. So SAN is nothing but you will be having a multiple nodes. Those are called zonal nodes. So those will be, I think those will be monitoring by Zookeeper only. Not sure, Poonam. I think they will be, yeah, those are maintaining by Zookeeper. One second, I have some document for that, yeah. But there's an administration stuff I really didn't see much. Let me see that. Let me see that I do have. There are different ways of setting up the cluster. So that's the reason I lost it. Federation. Federation. Data. Architecture. Not federation. High availability, right? HA. High availability. It is from the cloud era. This is one way of doing shared this thing. This is one way of doing quorum based missions. This is one way of doing. Okay. So there is one more. Okay. This is
What
one
is
way.
general node? I mean,
Zonal nodes are
quorum
some.
based.
Yeah, zonal nodes are something like who maintain this storage area network. That's also different missions. I really didn't get much in them, Ajit.
Okay.
Yeah. So see here these are the zookeepers. This is the maintaining of this information. So there are different ways of creating high availability. So there are three different ways. So this is one. One is a quorum based, right? So let's
Mostly which architecture will be used in real time?
zookeeper. I see that most of them are using zookeeper, because zookeeper is a good in orchestry services, like um, orchestry services in the sense like if name node goes down, one name node goes down, telling to the active name node to become active, standby name node to become active. So that kind of coordination between the services. So the Zookeeper is a good tool.
Okay.
Zookeeper is an application
It's
which
an
will be
application.
installed.
Correct. It's an application.
And it will be not part of the Hadoop cluster?
No, it is not part of the Hadoop. So individual also you can run the Zookeeper.
Okay.
Zookeeper has to install in odd nodes, odd number nodes, like a 3, 5, 7, like that, because it follows the leader follower architecture. There will be one leader and following followers will be there.
Do we need to learn more about the Zookeepers?
Not required.
Like how it's configured?
In Kafka also we use the Zookeeper. See, if you have an understanding what is Zookeeper, how it works, it's enough. So you really no need much details about the Zookeeper.
Okay.
Okay. So any other questions, guys? Let me see in chat window. Santosh not okay. Okay, he's just. It's clear. Yeah, fine. I hope it looks everyone is quite good. Tomorrow we will do the environment setup. So then we'll do the hands. We'll do the Hadoop commands as well. Okay.
It's okay.
Yes, sure.
Any other doubts? This is the theory part, guys. There is a lot to see. There are lot of commands are there. Yeah, we have a tomorrow session. Yeah, we have again 7 o'clock. Or 7. See, 7 means most of the time it will be start by 7:10, 7:15. So yeah, today also started by 7:15, I think, right?